Here's our sample problem number 1 for our uniform circular motion. The problem reads, a 1,650 kilogram race car is traveling around a circular path as pictured. The radius of the track is 225 meters and the car completes one lap around the track every 37.7 seconds. So part A has us draw and label the velocity, acceleration, and force vectors of the car on the picture right here. So if we take a look at first the velocity. Well, velocity is always the direction the object is traveling, and when the object is right here, the velocity is always in a straight line tangent to the circle. So this is our velocity vector right there. And then our force vector, our acceleration vector, either one, is always towards the center. The force causing this object to move in a circle is what's called the centripetal force, and net force and acceleration are always in the same direction, so they can be represented by the same vector, at least when you're talking about direction. Now when you're talking about the size of the vector, they will not have the same size. Maybe on a very rare, odd occasion, but that's not the norm. So with this problem, it's also going to be important to identify our given information, and we can label that in part A as well. So the given information in our problem, we have a mass of 1,650 kilograms. We know the radius of the track, so that is R, is 225 meters, and the time it takes to go around, which is 37.7 seconds. I label this as a capital T because when you're going in a circle, you have a more specific time, which is the period, which by definition is the time it takes to go around one cycle or one circle. So part B, calculate the speed of the car, which is our tangential velocity, which is what that little t stands for. It does not stand for period. This is not the period of the velocity, it is the tangential velocity. So our formula to calculate tangential velocity is 2 pi r, which 2 pi r is how you calculate the circumference of a circle, which is the distance that a car travels when it goes around the outside of a circle. And then the period is simply the time it takes. So it's still distance divided by time, but when you're going in a circle, your distance looks a little different. So we can substitute in our numbers. 2 is just a numerical value. Pi is 3.14 on-in number. And then we have our radius, which is 225. And then we divide that by the period, which is 37.7 seconds. So I like to put this in the calculator just directly. So 2 second pi, which on your 84 plus, the pi button, you would have to hit the second and then the button with the caret on it. So you can see the little pi right there. And then 200, and you can just plug it straight in like that and hit enter. Or then you can divide by our period, which is 37.7 seconds. So we end up with a velocity of 37.50 seconds if you're rounding to 2 decimals. Because this is 37.499, that 9 makes that third 9 makes the second 9 round up, which that 9 makes 4 round up. And that is how you find the tangential velocity, or the speed of the car. Then our next problem has us calculate the centripetal acceleration. So we have A sub c. You have seen A sub g before, which was the acceleration due to gravity. So it was a specific acceleration. This is also a specific acceleration, not a given number, but it is your centripetal acceleration. The formula for that is your tangential velocity squared divided by the radius. Most people, if they're going to miss this because of a math error, it's because you forget to square. So don't forget to square. We know our velocity, so we can pull that down from our previous answer. So we have 37.50 divided by the radius, which is 225 meters. Again, don't forget to square, which I almost didn't write that down. Normally what I do is I don't round, I just go straight out of the calculator and hit square, divided by 225, which gives us an answer of 6.25 meters per second squared. Oh, I wrote down the wrong unit up above. That would be meters per second. Sorry. Okay, that is how you calculate the centripetal acceleration. Now, to calculate the net force, which is the centripetal force, which is mass times acceleration, specifically mass times centripetal acceleration. You take the mass of the car, which is 1,650, times the acceleration, which we can pull down from here, 6.25, and that is simply equal to, I can take that answer, multiply by the mass. Oh, not divide, multiply. And that gives us a net force of 10,312.01 newtons.